All right, so I had a couple people asking about the SohCahToa that we started in class. The big idea here is that if you've got a right triangle, and if you know what this angle is right there, then you automatically know what the side lengths are going to divide to equal. And that was the whole idea behind that investigation where you were trying to have the little triangle here inside of the bigger triangle. And you could imagine if I extended it out, there'd be even bigger triangles. The whole idea is that if this is my angle right here, if I divide the vertical side by the horizontal side of the little baby triangle, and if I divide the vertical of the horizontal by the medium sized triangle, and if I divide the opposite and the adjacent of the huge triangle, that I'm going to get the same answer. And then this kind of makes sense because if you keep the angle the same, but you enlarge the shape, the two sides grow by the same amount. And so if you divide those two sides, you always get the same number. So the process of doing that, there's basically three different side pairs you can divide. You can divide opposite divided by adjacent. You can divide opposite divided by hypotenuse, and you can divide adjacent divided by hypotenuse. You could also do those upside down, and sometimes you will hear people talk about the upside down versions of these trig ratios. When I say trig ratios, I just mean you're dividing two sides of a triangle. And so those are the three main ones. You can solve every problem using these three ones. Sometimes people will use the upside down versions. There's a special button on your calculator, that's the tangent button, and that works when you're dividing opposite and adjacent sides. Similarly, when you're doing opposite and hypotenuse, you're going to hit the sine button. When you're doing adjacent and hypotenuse, you're going to hit the cosine button. And so that's where the word SohCahToa comes in. It's just a way to help you remember. I kind of wrote it out of order here. That's just to help you remember that tangent is opposite over adjacent. So that's what TOA means. Sine is opposite over hypotenuse. That's what so means. Same idea. Cosine adjacent over hypotenuse. That's cut. So the big idea is just if you know the angle in a right triangle, then you know what the sides divide to equal. So let's do an example. Let's say I've got a right triangle. I know one of these angles is 30 degrees. Here's my right angle. And let's say that I know this side here is 5, but I don't know what this side is, and I don't know what this side is. Well, this side is called the adjacent side because it's touching the 30-degree angle, and this side is the opposite because it's not touching the 30-degree angle. And this is the hypotenuse because it doesn't touch the right angle. So I can use sine and I can use cosine. Tangent wouldn't help me here. Think about why tangent wouldn't help. Tangent wouldn't help because I don't know what the y value is and I don't know what the x value is. I don't know either of the two pieces that are involved with tangent. Okay, remember. So, SohCahToa, I don't know the opposite. I don't know the O. I don't know the A, so it doesn't work. If I set up sine of 30 degrees, that's going to be the opposite side divided by the hypotenuse, y divided by 5. Okay, now on your yellow calculators, you've got buttons on there that are sine or cosine or tangent. If you're going to use your phone, you got to turn it sideways to make it work. So I'm going to go 30 degrees and I'm going to press the sine button. Type it in that order, 30 degrees and the sine button. So what that's telling you is that if you have a 30-degree angle, then the opposite side divided by the hypotenuse is zero point 0.5. In other words, the opposite side is half as big as the hypotenuse. So then how do I solve this for the letter y? You just multiply both sides by 5, and you get 2.5 as the letter y. Now you got two sides of the right triangle, so you could do a squared plus b squared equals c squared to find the other side, or you could use cosine, because cosine is going to be the adjacent side over the hypotenuse. So I'll do the same thing. I'll go 30, and I'll hit cosine. So that gives me 0.866, and then times 5 to get rid of divide by 5. and I get 4.33. And that's the x value. You can always double check that your two sides work with the Pythagorean theorem. There's one version of this that's a little bit trickier. And so let's say that we have a triangle, looks like this instead. This is 41.5 degrees. And then let's say I know that this is 5 over here. So here's the adjacent, and here's the hypotenuse. And I hope you can see why this is just a little bit trickier. Let's say I want to find this. We'll call this x, we'll call this z. Let's say I want to find x. Well, I could use tangent because I know the opposite and I don't know the adjacent. So let's set up tangent. Tangent of 41.5 equals opposite over adjacent. But the tricky thing here is if I type in 41.5 and I hit the tangent button, I can write that down just fine. 0.885 equals 5 over x. But I can't just multiply by 5 to solve this now. X is on the bottom of the fraction. So we got to just do two steps. You still want to multiply to get rid of the fraction, but now you have x times 0.885 equals 5, and then you divide to get rid of multiplication, and then you got it. So x equals whatever 5 divided by 0.885, 0.885 is. So x is going to be 5.65, like that. So that's all it is. Practice it some more. There is so much SohCahToa practice out there online. You just Google it, Khan Academy. It's all that. Or really, I just drew random triangles. I just threw an angle on one side and put a number on one of the other sides and found the other ones. And you can always double check that you got the right answers by just using your good old friend a squared plus b squared equals c squared. All right, so thanks for watching. Like or comment if there's anything I could do better. Appreciate it.